Okay, so I'm going to record a short video uh, with the intent to describe the functionality of the robot sensors and the compass, IR sensors, and how we can use those to solve the maze for the final project. And so we need to understand how the sensors work before we can understand what questions to ask to be able to use those sensor inputs to make our decisions that we need to make. So if we go under the final project folder, and under the development and testing folder, we have a few things here. Okay, we have this final project theory of operation. I'm going to talk through that. And so here we're going to have a couple different things. Okay, we're going to have what the task is that we could be trying to accomplish, right? And so each team member will have a specific task. Maybe one of them is following the line, so it's your responsibility to have the robot follow the line. You will want to use a code that looks like this, actually exactly like this. And that will allow the robot to go and look with its sensors that are on the front bottom of the robot underneath this metal guard. It'll allow those sensors to look and to see what value they read, and that takes that value and determines where the line is. Okay? If the value is a 0, then the line is underneath that sensor. If the line is not under that sensor, the value is 2500. Okay, so that's the range of values. Now what this code will do is it will take a weighted average of all 6 sensors, okay, and it will determine based on that weighted average value where it thinks the line is. And it's actually fairly accurate. Okay, and so what I have here, let's go under the assumption that we're perfectly aligned with the middle of the robot. So this black, solid black line is right in between the set 2 sensor and the 3 sensor. And we're running along and we're reading that line value. We're going to get a weighted average value that ends up to be 2500. Okay? If we weight across all those 6 sensors, the value that the robot will return will be 2500. If we assume that dead center on that black line is our target, we want it to be 2500 ideally to stay centered. If we're dead center on that, we can actually use our line location measured value and our target value to get a proportional error value, right? So we can use the error equation to calculate how far off the line we are. This is now a way that we have to tell ourselves, are we on the line? Are we off the line? How far off the line are we? Which then means how sharply do we need to turn back to the line? Okay, this is proportional control. The further away we are, the sharper we'll turn back. The closer we are, the less sharp. So here, what I'm trying to communicate is if the line is all the way on the left, we will get a line value of 0. Right? If our target is 2500, that's going to be a -1 error, okay? Which will tell us that we're too far, that the line is too far to the left, right? If we get line all the way on the right underneath the number 5 sensor, we're going to get a 5000, okay? Of course, that's a proportional error of 1, okay? We can think of that as 1% or -1%, okay? With the range in between. So right there, we're able to read the line location, put that value into an error equation, and get a return value of a proportional error that will tell us, and if we keep it as a -1 through 1 number, okay, which needs to be a float, okay, because there's decimals in between those, it will allow us to then know how far off the line we are and what direction we are off the line based on the negative or a positive value. So we can then use that number to ask questions and determine what we need to do to change the motor speeds. Okay, so there's 2 motors, one on each side of the robot, left and right tracks. And after we've read the line, here is our error equation that we would use to determine the percent error, right, the proportional error. And this number is going to be between -1 and +1. Then we would need to ask questions. I'm going to leave this up to you to determine what questions, if questions, most likely else if, you need to ask, okay, to determine if your motor, if you need to turn left, or if you need to turn right, or if you need to go straight. So depending on the answers to that question, or those questions, if you need to go left, this is the code that you want to use to turn left, okay? Motors.setSpeeds, in parentheses here, 100 times 1 plus error. That will change the speed of your left motor. Okay? If you slow your left motor down, you will turn left. So what you're doing here is you're taking 100% speed times some number between 0 and 1 percentage, right? We're going to turn that into a proportion, which is like a percentage. Okay, so we're reducing, in effect, my 100% left motor speed by some percentage. Okay, if the error is larger, I reduce that speed by a greater amount, so I turn more sharply. Okay, same with the right motor, except we go to the right side and we actually change this to a negative. Okay, that's important. Positive versus a negative. Okay, if we want to go straight, if we don't want to change at all, motor set speeds 100, 100. Nothing changes, right? If we're dead center on that line, we still want to go straight. So this is how we can use the sensor array underneath the front of our robots to determine where the line is and how far off we are from that line. And then, of course, how sharply we need to turn and what direction to turn. Okay? These are IR sensors, so they sense the difference between black and white. And a higher number means they see more black. A lower number means they see more white. So now if we come down and we say, okay, now what if I know I need to make a sharp turn? Okay, I don't need to follow the line, but I need to make a sharp right or left turn. We're going to use a little bit different code. Okay, we're going to use this code. Okay, and this is going to give us 6 separate values. Okay, and it's actually an array, and so sensor values is the array variable, and it's going to have a 0 through 5 element number, okay, corresponding to sensor 0 through sensor 5. So if we run that code and we look at the outside 2 sensors, those are the 4 sensors that we're going to be able to notice if they're black versus white. Okay, so if, for instance, the 4 and the 5 sensor are black and the 0 and the 1 see white, then we're pretty sure that we need to make a right turn. Okay, we don't need to concern ourselves with the 2 and the 3 because we're most likely already seeing black, right? Vice versa for a left turn. Okay, so this is something we would use. We would read the sensor and we would ask a question. Do I see 0 and 1 low, and do I see 4 and 5 high? Yes, I need to make a right turn. No, just keep going straight. Okay. One important note, we always have to measure before we ask a question about the sensor values. Okay, we need to get an up-to-date measurement before we can ask the question of what the values are. This is sharp turns. Okay. Okay, we know we need to turn, but how long do we need to turn for? Or how far of a rotation do we need to make? There's a couple different options we have. We can go by time. We can say, let's just tell the robot to start turning, and let's turn for half a second, and I don't care where I am or what's happening in the world, I'm just going to turn the robot for half a second. Okay? It's easy to code. Battery charge affects it. The surface friction affects it. Okay? You don't know if you've turned into something if you do it based on time. Okay, it's just like putting the blinders on, turning until you're done. We could also use the sensor array, so we could use those 6 sensors underneath the front of the robot. This is a medium to code. We have a little more lines to write. It's not affected by the battery life or any compass issues. But the con is that you do need to be aligned with the probably most likely the black line that you're on before you make the turn. So the assumption is, or the concept here is that you would start turning until you see the black line again, centered or close to center of your robot. Okay, so you have a sharp turn, or you're the end of the rows on the harvesting task, and you start turning until you see that black line again. Okay, it's medium, right? It's kind of in the middle. Then you could use the compass. This you can say, okay, turn 90 degrees, turn 180 degrees. It's harder to code. It's definitely affected by battery charge. It's also affected by the Wi-Fi and other cell signals. It's affected by the metal in the room. It's affected by the compass calibration. So this is a little more challenging, but you can get maybe some more robust results if you work through those challenges. So those are the three options that we have to turn and to decide how long we're going to turn for. And then we also need to be able to identify the black boxes. So this is very similar to making sharp turns, except we're going to look at the middle 4 sensors. Okay, if those are high, then we are pretty sure that we're seeing a black box. Okay, please make note of that the far left and the far right sensor probably don't care about those, because if you're trying to get those to see black as well, it's making it even more of a challenge to have to be completely perfectly lined up before you see that black box. Okay, so one of the things we need to be thinking about is we want to code our robots to ask questions, but to not ask too precise of a question. Okay, because they're not going to be perfect. They're not going to approach the black boxes perfectly. They're going to be a little bit off. So we want to have questions that say, if the middle 4 sensors are high, you see a box, because I don't care about the outside sensors. I might be off one time, or I might be on one time on the outside sensor. But I know that the middle 4, those are the ones, if I see all of those, 95% chance I'm in the black box. Okay, so that's what we can use to sense or to know where the black box is. And then of course on the harvesting one, we need to identify where this location is on the field. And similar, we're going to see low values on 0 and 5, high values on 1 and 4, and most likely we're not going to care about the 2 and the 3 sensor. Okay, because we're going to see black on that, so we can just assume that we're on black. Okay, I hope this was helpful. This is a quick overview. We're going to talk some more details in class as we have questions and we're working on this. But if we're going to understand how to use the robot, we need to understand how it functions. Okay, see you in class.